Everything we do, whether it's sending a message, making a financial transaction, or being on a Zoom call like right now, is encrypted. But how does encryption work? Well, it turns out that all of modern encryption is based off one simple concept. Math is hard. In fact, the most secure encryption scheme in history, the RSA encryption scheme, is built off the idea that factoring really, really big numbers takes a really long time. Even for the most powerful supercomputers in history, it could take up to 1 billion years to factor an industry standard size integer. But what if instead of working with classical computers that rely on classical physics, we consider a computer that relies on quantum physics, a quantum computer? Well, over the past few months, this has been my area of interest. And like many others who have explored quantum computing, I quickly ran into all of those headlines, fear-mongering that quantum computing will break encryption. But where do these headlines originate from? Well, they all originate from Shor's algorithm, the algorithm that is meant to break RSA. Since learning about Shor's algorithm, I have had two goals. My first goal was to truly understand how Shor's algorithm works. My second goal was to see it work in action on my screen. So after weeks of studying Shor's algorithm, I was finally confident enough in my understanding to replicate it on my own screen using an IBM tutorial and factor the number 15. But how does Shor's algorithm work? Well, broadly there are just four simple steps. The first thing we do is we take the unfactored integer and construct a sequence, such that within the order of the sequence lies information about our factors. Next, we want to consider something called the superposition of all possible orders. This is just the probability of each possible order occurring as the result of the algorithm. So now what we want to do is increase the probability of the correct order and decrease the probability of the incorrect order. But how do you do this without knowing what the order is? Well, instead of order, let's think about time systems. Imagine you live by a 17-hour day, maybe a 26-hour day, maybe a 24.7-hour day, maybe any other possible day you could imagine, but you don't know. How would you figure it out? Well, I would have a wall with every possible clock, and each clock would have a sticky note and a thumbtack in the middle. Now, every day, I'd go to the clock, each clock, and I'd look at where the hour hand is pointing. Then I'd go to the corresponding thumbtack and move the thumbtack 1 inch in the same direction as the hour hand. Now, after enough days, the thumbtacks corresponding to the incorrect clocks will drift back towards the center. But the thumbtack corresponding to the correct clock will move further and further and further away from the center, because relative to that clock, every single day you've been waking up at the exact same time. Therefore, you'd be moving the thumbtack 1 inch in the exact same direction until it's not even on the wall. Well, it's a similar idea with Shor's algorithm. We negate the incorrect probabilities and emphasize the correct probabilities. So now that we have our order, all we do is we use a classical computer to factor out our information on the factors. So why is encryption not broken? It's simple. There just does not exist a strong enough quantum computer. But I believe over the next few years, they will make one, and we will all have to move to quantum safe encryption. Thank you.